So hello and hope you're doing really good and welcome back to my channel once again. Today we are at day 5 of the July Daily Leetcode Challenge. Yesterday we had a very nice question which is on bit manipulation, and I made a detailed video starting from scratch to a very advanced level. If you are able to see that whole video, please have some time, you know, time where you can really concentrate, have some time, have a paper and pen to note. Definitely watch that video. It will be really useful for you, right? Yesterday's Daily Leetcode Challenge, which is on bit manipulation. Now coming to today's question, it's again a medium level question, and it's actually not that difficult. It's just a simple question. Okay, it's question 1493. Longest array of ones after deleting one element. Okay, so from now on we'll be ending the streak for the bit masking and backtracking. So today's question is very different question. It's not related to previous questions. So from the last few days onwards, we had the continuously related to bit masking and backtracking, but for the first time now we are having a different question. Okay, so longest subarray of ones after deleting one element. Let's see what the question is. You can clearly see the input is going to be a array of integers. Okay, remember it's going to be a binary array. Okay, only ones and zeros are present. Okay, if you are given a binary array nums, you should delete one element from it. Okay, return the size of the longest non-empty subarray containing only ones in the resulting array. Return zero if there is no such array. Okay, what they are trying to say is, if for example I remove this zero, then I will have ones present altogether. Okay, all the three ones will be combined. Okay, so that will be a subarray. Okay, so the length of such a subarray is 3. Okay, so what they are trying to say is, after removing one element, okay, which element to remove, that we have to decide. But after removing that element, we have to return the size of the longest. Okay, the longest non-empty subarray containing only ones. So please highlight these words: longest subarray. It's a subarray, not a subsequence. Remember, longest subarray containing only ones. Okay, these three words if you highlight, you will get the whole motto of what they're trying to say. Okay, longest subarray containing only ones. Subarray basically means that, see, for example, if I take these three, these can only be combined with these two. Okay, that these three can be combined with these two. Okay, similarly these two can be combined with this one. Okay, that's what they're trying to say. Okay, so these three cannot be combined with this one because they will not form a subarray as such. Okay, we can remove only one zero between them, right? That's what they're trying to convey, and we are talking about subarrays and not subsequences. Okay, remember that thing. So yeah, in the first time we can see the length of, see, after you remove zero, the length of ones will be 3. They will be together, clubbed together, so it will form a subarray, and they will form the maximum subarray containing ones. Okay. Now come to this case. These are 3 here. These are 2 here. So what I will do is I will remain. I will remove this zero. Okay, this particular zero. What will happen is these three will get combined with these two. It will form a length 5. Okay, a subarray of length 5. That's what 5 is the answer. In this case, you can see all are ones, but remember we have to remove an element. Okay, we should delete one element. So in this case, any one we have to delete, so the remaining goes will form a group and it will be of length 2. Okay, so that was all. Let's see the solution now. I am designing solution which is going to be often. Okay, the space complexity is also often and the time complexity is also often. Okay, we'll see that. So counter once I'm going to create array. What this array will store? This array will store the length of. I will show you that how it works. Okay. So what the idea here is, I will just quickly run this and show you so that you will get the idea. Then it will be easier for you to understand. Okay. For example, see here, I will store the length of the subarrays. Okay, I will in this array. I will show the length of the subarrays. What it means is, see, this patch has a length 3. Okay, this patch has a length 3, so 3 will be stored. Similarly, this patch has a length 2, so 2 will be stored. Similarly, this patch has a length 1, so a 1 will be stored. Okay, that's what it is. So what the idea here is, whenever we see a 0, whatever ones we had previous to that, that will be stored. Okay? For example, this 0 came. Behind that, that is left of that, there were 0 ones. Okay, so 0 came. This 0 came. Behind that, there were, that is left of that, there were 3 ones. So 3 came. Okay, and so on. Okay, for example, this 0 came. Behind that, there are 2 ones. So 2 will be stored. And similarly, remember for the last one, this will also see, it's not followed by a 0. Still, we will store its length. Okay, its length is 1. That is what we're going to do. Then what I will do is, see, I will just iterate over the continuous elements. Then I will add, for example, I will add 0 and 3. Okay, then I will add 3 and 2. Then I will add 2 and 1. Whichever contributes the maximum sum, that I will take. Okay? For example, in this case, 3 and 2 contributes the maximum sum. So that will be my answer. That's what I'm going to do. So for that, here I'm using the count of ones. It will show the count of the subarrays of ones. Okay, then the length of the nums array. Okay, and the count equal to 0. And it will be the count, patches count. Okay, count of each subarray. We'll see that. Okay, once we trace, we'll get to know why we require these things. I will let you know, but just for now, just for ignore it. Okay, I'll just keep enter here. Okay, So for I in n, so that is I'm going through each of the elements of the nums array. Okay, what will happen is if it is a zero, okay, if it is a zero, whatever is your count, simply append it to the counts of one array. Okay, whatever is your count, append it to the counts of array. Reset the count. Okay, reset the count. If it is anything else, that is, if it is one, add the count by one. Okay, try to understand what I'm doing. Whenever I see a zero, whatever is the previous count that I'm updating, that is I'm appending in my array. Okay, appending in my counts of ones array, and I'm making the count as zero. Okay, this count is now appended. After that, it is made zero. Okay, if it is a one, what I'm doing, I am simply adding the count. Okay, but remember one thing is happening here. See, if you see this particular test case, what is happening here is, see, there are three ones. Okay, there are three ones, but I have to remove one element, right? I have to remove one element and I have to do that. So for this reason, I have set a new variable called zero present. Okay, if zero is not present, if zero is not at all present, what will happen is, there will be count of only ones. There will only be, see, in this array there will be only single answer. Okay, in this array there will be single answer if no zero is present. Okay, that's why I've created a variable called count present equal to false, initiated to be false. When I witness a count, I will made it true. Okay, so when I come out of this loop, I will just check if, yeah, this is done. See, if it will test that if the last element of the num is one. Okay, because see, what we are doing is, try to understand here. See, whenever we see a zero, basically, see, whenever we see a zero, we are updating the counts of the ones to its left. Okay, but for the last one, there is no zero to its right. Okay, so what we'll do is, for the last one, we have a special condition here. If the last element of the num, see, this means last element of the nums array, if it is one, in that case, still update the count. Okay, still update the count. In this case, what we are doing, only when we are seeing a zero, we are the ones to its left will be updated. The count for the ones to its left will be updated, but for the one to its right, okay, one at the extreme end, this one, there's no zero to its right. Okay, so it is not at the left of any zero. So for this we need a special case. Okay, so if the last element is one, we are also same condition, whatever you're seeing here, same thing is copied here. Okay, same thing is coming here. Okay, this is for the if the array is ending with one. Okay, that is there, then I'm printing it. Okay, now comes the condition. Okay, if zero present equal to false, that is there is no zero present. Okay, if there is no zero present, what will happen? My answer will have, the array which I'm maintaining will have only one element. Okay, it will have only one element, which will be the length of all the ones. Okay, I have to simply subtract one from it and return it. Okay, this particular array which I'm maintaining will have only one element, I'm referring to that, then I'm subtracting one and returning it. Okay, that's what I'm doing if there are no zeros present. Okay, in every other case, even if a single zero is present, definitely at least two elements will be there in this answer. At least two. You see, only if the zero is not present, there will be only a single element in this answer. Okay. In all other cases, there will be at least two elements in this answer. Okay. That's why I am doing this calculation. I am adding the first two elements. Okay. The first two elements, that is zeroth element and the first element. Okay. The first element and the zeroth element, I'm adding it. I'm showing it in my answer. Okay. Then I'm starting the loop, starting from index 2 till the last index of this of the length of the counts of one array. Okay, what I'm doing, I am adding the ith element with the I minus one element. Okay, and I'm checking if it is greater than or equal to answer. If it is greater than or equal to answer, that is, if it is greater than answer, then update the answer. That's what we're doing. Okay, if I can trace and show here. Okay, just see in this example. See, what I'm doing is, see, this zero came, that's why the number of ones to its left is zero. Then this zero came, the number of ones to its direct left is three. Okay. Then this zero came, the number of ones to its direct left is two. It came. Okay. Then this, for this one we have updating here. Okay. Fine. Now what we're doing is, see, I have added the first two elements to form my answer. Okay, then I will start from the second element onwards and add it with my I minus one element. Okay, that is for every two consecutive numbers I'm adding it. Okay, for every two consecutive pairs I'm adding it. Okay, to check which of them are going to be. See, that is what is called subarray, right? See, if I remove this zero, see, if I remove this zero, what will happen is this and this will merge together. Okay, that's what the idea is. Okay, similarly, if this zero is removed, what will happen is this two and this one will merge together. That's why I'm checking which one of them will yield a maximum sum. That will be my answer. That's what I'm trying to do. Okay. See, that's what I'm doing here. Whichever sum is yielding the maximum, I and this previous element, that is I minus one, whichever one is yielding the maximum, that is taking the answer. Okay, and finally I'm returning the answer. Okay, I will quickly run this and show you. It's nearly 80% faster. You can see it's clearing all the test cases, and if I comment it out this print, then I can, yeah, now this code is ready. So if we talk about time complexity, what is happening is, see, basically, I'm going through each element, and then I'm again going through this. So what will happen is, let us assume in the worst case, if we have all the zeros present, okay, there is not even a single one. Then what will happen? Then the length of this also will become the same as that of my original array. That is this array. Okay. So the length n, see, length n is the length of nums, right? This also will have become a array of length nums. Sorry, array of length n. Okay. So this will be O of n. Okay. This also will be O of n. Okay. So the time complexity is again going to be often in the worst case. Remember, in every other case, it will not be of often. Okay, it will slightly less than that. Okay, this particular highlighted code will not be of often. Only in the worst case it will be of often. Okay, and this always will be often. Okay. Now coming to space complexity, again in the worst case, what will happen is, as I mentioned, what will happen is this thing will become the length of the nums array if all of the nums elements are zero. Okay, so that is in the worst case. The space complexity also will be often. So often that this is a simple solution which I can think of. Okay. There are many ways to do it, but I felt this solution came to my mind at first. That's why I just quoted it, and it got accepted. That's why I'm bringing through this solution. See, there are many ways to do it in this kind of questions. Okay, there are many ways to do it, but I've tried to bring to you the simplest approach possible. Okay, so often that was all for today. If you are not, please do comment below. If you like my solution, then please subscribe to my channel and give a like. Okay, and one important thing which I want to tell everyone is that yesterday's video, I've put in lots and lots of effort for the yesterday's video. I've taught the bit combination from level 0 to the advanced level. Please have some time and then watch this video. If you did not like it, definitely no need to watch, but I can assure you that if you want to learn bit manipulation and if you see that video, definitely you will be good in your basics and you will have a complete idea of what is bit manipulation now. That I can assure you. Okay, please have 15-20 minutes and then watch this video. Have a pen and paper to maintain notes. Definitely will get something out of it, right? Thanks a lot. See you tomorrow.